Okay, so I want to talk to you guys in a little bit more detail about the sample variation aspect of the conclusion again. So when we started this internal, we would have done some investigations and realized that every single sample we take from the population can be slightly different. And we've got to be able to talk about that. So just to illustrate that again, there's a couple of animations I can show you. And we'll look at this one. Sorry they're on super high speed, I can't really slow them down. But if we take a look at the sample size of 20 here, so on a sample size of 20, you can see there's samples just being taken continuously here. And there's quite a bit of variation between them. You'll notice that median is bouncing around all over the place, and the box and whisker is also extending and kind of moving around. On the sample size of 100, you'll notice the median is bouncing around, but not nearly as much. And the middle 50% is also changing, but again, it's looking better than the sample size of 20. And if we manage to take a sample size of 500, you'll notice the median is not moving at all, really, or very little compared to the other two. And our box and whisker graph actually stays a reasonable width the whole time. So if we take a look at the overlap of these box and whisker graphs bouncing around for each different sample that we take, and just look again for a minute, notice those dot plots, they're slightly different each time, so each different picture you see here is of a new sample being taken, and you can see that every sample is actually slightly different. Again, that's our sample variation. So if we look at just overlaying the box and whisker graphs on top of each other, the red ones show you where the box and whisker, where the box has been, the middle 50%, and the blue lines show you where the median is. You'll notice for a sample size of 10, the width between the blue lines is actually pretty spread out. So there's a lot of variation between the medians of those samples because they're really all over the place. You'll notice the width of the blue where the median is on these samples is starting to narrow down if we go up to a sample size of 100. But there still is some variation. And you'll also notice the box and whisker, the box is staying at a similar width, but it's still bouncing around a bit, but again much better than a sample size of 10. And for a sample size of 1,000, our median is really, really narrowing down and staying pretty consistent. And same with our middle 50%. It's moving around a little bit, but really not much. And this, if we knew it, again, we don't always get to see the population, but the population wouldn't be moving at all because we know exactly what the median is there. So just as you watch these, the further away you are, the smaller your sample size, the more likely you are to get samples that are kind of ridiculous and nothing really near the population. But if we increase our sample size, we notice that each of our samples kind of stays more consistent or becomes more consistent to what we actually see in the population. And obviously, the bigger the sample, the more like the population it is. And that's the idea we're trying to drive home in these paragraphs. So, if we look at these again, this idea of what would happen if I took a larger sample. If this was a sample that I had taken, and you can see in this case, my confidence intervals are not overlapping, and they're actually shifted quite far apart from each other. So where my confidence intervals are, I see there's no overlap between the two of these. And there's a reasonable shift. There's no overlap in the middle 50%. There's no overlap in the confidence intervals. And so if I took a bigger sample, my confidence intervals are actually going to narrow down. And we have to remember that idea that bigger samples make our confidence intervals smaller. So again, if it's a reasonable sample, I'd expect that the middle 50% and the median to be similar, but they could be slightly different. But the most important change for me is that with a bigger sample size, my confidence interval is going to be smaller. And to illustrate that one more time is this idea here. Think about the width of that blue. That would be how wide your confidence interval is here. So for a sample size of 10, my confidence interval would go fairly wide. You can see kind of the distance of that circle sliding back and forth. But my confidence interval for 1,000 would be really narrow, because I would basically take that blue width there and I'd say, well, I'm pretty confident the population median is somewhere inside of there, because all my all my samples are sort of in that range. So here you can see, if you think about that blue as the confidence interval, it is getting smaller the bigger sample you take. So here, we'll notice that my confidence intervals are going to shrink up slightly. And if they're already far apart from each other, and they're already not overlapping, if they get smaller, even if my median's moved around a little bit the next time around, it's likely that they're not going to overlap again. So they were not overlapping, and if I take a bigger sample, they're probably not going to overlap either, because, yeah, my medians could move around a little bit, but my confidence interval is going to be even smaller, so it's going to be harder for them to overlap. And so your statement here would be, if I took a larger sample, the confidence intervals would be smaller. The medians will be different too, but in this case, the confidence intervals are already well separated with no overlap. So even with a much larger sample size, it seems likely that I will make the same conclusion, that the trees near the river produce more apples than the tree far from the river. So there you'd have to put it into context, right? So whatever it is you're actually talking about. Next example. So again, this is not overlapping. This is my case where my confidence intervals are overlapping, but they're also shifted further apart from each other. So you can see here I do have some overlap between my confidence intervals. So my conclusion here would have been that there was no difference between these because of the overlap. Versus on this one, I would have had a difference because there was no overlap. And I get the same thing over here, a difference. Again, still no overlap. But what's the potential here? I see that I have no difference at the moment because I do have an overlap. But if I take another bigger sample, remember my confidence intervals are going to get smaller, and my medians might bounce around a little bit. So there's a chance here, like you can see illustrated here, that with a smaller confidence interval, you'll notice those confidence intervals actually don't overlap. So here I might get a totally different conclusion that says I actually have a difference because there is no overlap. So I could get a different conclusion. All the same in this case too, it could go either way. I could potentially get medians with smaller confidence intervals, but again, because of sample variation, things might move around a little bit. And it's possible that I could still get no difference and an overlap. And so we're not really sure. In this case, we might want to say something like either way, right? I might get the same conclusion or I might not. So if I took a larger sample, the confidence intervals would be smaller. The medians will also be different. So in this case, it is possible that I could make a different conclusion as the smaller confidence intervals might not overlap, and I would conclude that there is a significant difference. So again, that's this idea that with big confidence intervals, I see the overlap and I would say there's no difference, but with smaller confidence intervals, I might end up with a situation where I would say there's a difference because there is no overlap. My last example here would be when confidence intervals are well overlapping and not shifted. So here, yeah, my middle 50% is shifted slightly, but my confidence intervals are pretty damn well overlapped. So even if they bounced around a little bit and I got new samples with smaller confidence intervals because I took a bigger sample size, in this case, my confidence intervals are still overlapping. So here we would say there is no difference because I have an overlap. And with a bigger sample size, I might get the same thing again, that there's no difference because there still might be an overlap. I don't know for sure, but it's possible. So if I took a larger sample, the confidence intervals would be smaller. The medians will also be different, but in this case, the confidence intervals are well overlapping, so it seems likely that even with a much larger sample size, I will make the same conclusion that the trees near the river produce the same amount of apples. Same amount of apples as the trees far from the river. And again, you'd want to make that into your own context, whatever it is you're actually writing about. So you have to think really, really carefully about what you would say. Just this idea again about look at what you've got for your small sample of relatively 30 or 20 or whatever you've taken, and think about how that might change if you had a different sample with a sample size of 100 or 40 or a bigger sample. Is it possible you'd get the same conclusion, or is it possible you might get something totally different? And again, have that visual in your head of this idea that the samples might be bouncing around a little bit, and if you've got a bigger sample, you're going to have a smaller confidence interval. You have a better idea of where that population median is. So what happens to your conclusion when those confidence intervals shrink up?